Question 6, a difficult question this, because you've got to work it out and talk about things theoretically. You've not got all of the numbers. You talk about how you would do it rather than come up with an exact answer. Anyway, this question is about calcium compounds. A pure solid is thought to be calcium hydroxide. Calcium hydroxide reacts with 2 moles of HCl hydrochloric acid. Makes calcium chloride and water. And then what you can do is you can take any unreacted acid. That gives you a clue. Unreacted acid, it means that we've got excess acid. We're going to use up all of the calcium hydroxide and we're going to have unreacted excess acid. That might be important. So the excess acid that you've got left over after the calcium hydroxide is reacted can be determined with titration with standard sodium hydroxide. So what you do is you take the leftover acid and you react it with sodium hydroxide. You know the concentration because you've made it up to a certain concentration of the sodium hydroxide, and you can work out the volume of sodium hydroxide that you've got to add from a burette. And knowing the concentration of the sodium hydroxide that you're using and the volume that you're using, you can work out the number of moles of sodium hydroxide that you need to add to react exactly with the HCl. Therefore, you can work out the number of moles of HCl that you've got reacting or left over, and therefore you can work out the number of moles of calcium hydroxide. That's the way it's going to go. Let's see it now in more detail. So you're provided with 50 centimetre cubed of 0.2 mole decimetre cubed hydrochloric acid. So first of all, before we go any further, let's work out how many moles that is. We've been given a volume, we've been given a concentration, so let's work out the number of moles that we've got. So what you do is concentration is moles divided by volume. Moles is concentration times volume. Concentration is 0.2. The volume is 50 centimetre cubed. We've got to get into decimetre cubed. A centimetre cubed up into a larger unit value, decimetre cubed, you divide by 1,000. So it's 0.2 multiplied by 50 divided by 1,000, 0.01. That's the number of moles of acid that we've got. So experimentally, how much calcium hydroxide would we use? 1 mole of calcium hydroxide reacts with 2 moles of acid. So if we take that number and we divide by 2, that comes out as 0.005. 0.005. Now, how many grams of calcium hydroxide are we going to need? It doesn't tell you, so let's work it out. So the MR of calcium hydroxide is 74, so it's 40, add 2 16s for the oxygens, add 2 1s for the H's, it comes out as 74. Mass is 0.005 times 74. It comes out accurately as 0.371. That's the number of grams of calcium hydroxide that would react with 2 moles of acid. However, in the question it says that you've got any excess acid, any leftover acid. So we've got acid in excess. So that amount of calcium hydroxide would use up all of the acid, so we need something less than that, less than 0.371 grams. Anything less than that would leave some of the acid left over. The next stage then is you've got to get this leftover acid. You get the leftover acid and you measure it out. So we're going to measure it out 50 centimetre cubed using a pipette. And add the weighed amount of solid to the conical flask. So you get 50 centimetre cubed of the acid that you've got here. It says you provide with 50 centimetre cubed. Let's use a pipette. Let's do it accurately. 50 centimetre cubed using a pipette, and you add the calcium hydroxide. Okay, and then the leftover acid you're going to titrate against sodium hydroxide. It says a standard solution of sodium hydroxide. Now when you titrate anything, you usually use 0.1 as a concentration. So 0.1 is going to be the concentration of sodium hydroxide that you're going to add. And you have the sodium hydroxide in a burette and you'll be adding it. You'll have the leftover hydrochloric acid in a conical flask that you've mixed with the calcium hydroxide, so you'll have that underneath. You'll have to add an indicator. The best indicator to use, incidentally, is phenolphthalein. Phenolphthalein, it means that when the sodium hydroxide just reacts with the hydrochloric acid and then you add 1 more drop of sodium hydroxide, the phenolphthalein in excess sodium hydroxide goes a nice pink colour. So phenolphthalein is good to use if you're adding sodium hydroxide from the burette. And so you can titrate it. Now this is the complicated bit. How are you going to work out the relative formula mass of the solid? So that you've added the calcium hydroxide to work out whether it is indeed calcium hydroxide, because they think it's calcium hydroxide, they're not sure. If they can work out its MR, then they can prove almost, I suppose, that it's calcium hydroxide that they've got there. So how do you work out the MR from this experimental data? Well, from my titration, I've just added sodium hydroxide. I know the volume of sodium hydroxide that I need, and I know its concentration. So for sodium hydroxide, concentration is moles divided by volume, so I can rearrange that so moles equals concentration times volume. I know the concentration of my sodium hydroxide because I made it up to a certain concentration and was suggesting 0.1. We know the volume that we've had to add from the burette, so we know the number of moles of sodium hydroxide. Now, sodium hydroxide, NaOH, reacts with HCl. 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid, and it's going to make NaCl and water. So the number of moles of sodium hydroxide that I've just worked out that I've got is equal to the number of moles of HCl that's left over in this reaction. Let's call it X. Let's just call it a value X. So the moles of HCl that have reacted, the moles of HCl that are unreacted is X. The moles of HCl that are reacted are however many I started with. The number of moles of acid was 0.001. Take away X. So that's the number of moles of acid that have reacted. That's the number of moles of acid that are left over. I started with 0.1. I've got 0.01 moles of acid. I've got X number of moles left over. So the amount that I've actually reacted is 0.01 take away X. Now, hydrochloric acid, 2 moles of hydrochloric acid react with 1 mole of calcium hydroxide. So the moles of calcium hydroxide that have reacted is 0.01 take away X, the number of moles of hydrochloric acid, divided by 2. And when you get the number of moles of calcium hydroxide, MR is mass multiplied by moles. You've got the mass. The mass that you've used was 0.371 or slightly less than that, but you know its mass, you know how much you've added. Mass divided by moles will give you the MR, and hopefully if it is calcium hydroxide, then it will turn out to be around 74. A 3.56 sample of calcium hydroxide was dissolved in water and reacted with an excess of sulfuric acid to form calcium sulfate. The percentage yield of calcium sulfate was 83.4. Calculate the mass of calcium sulfate formed. Give your answer to an appropriate number of significant figures. Well, these are to 3 significant figures, so we better put it to 3 significant figures. Let's have a look then. The moles of calcium hydroxide. So, I've got 3.56 grams of calcium chloride. So I could work out the MR of calcium chloride. I've got calcium chloride here in my previous equation, if I wasn't sure, CaCl2. So that's a 40, add 2 35.5s, and so I know it's 111.1 is the MR of calcium chloride. So moles is mass divided by 111.1. 3.204 times 10 to the minus 2 is the number of moles of calcium chloride. The number of moles of calcium sulfate that I would make is exactly the same, because calcium chloride then reacts to make calcium sulfate, and 1 mole of calcium chloride will make 1 mole of calcium sulfate. So the number of moles of calcium sulfate is exactly the same, 3.204 times 10 to the minus 2. However, I've only got a percentage yield of 83.4%. I've lost some of it along the way. So the actual number of moles is 83.4 divided by 100. That's a fraction. So it's a percentage as a fraction. Multiply, I actually make 2.672 times 10 to the minus 2 moles of calcium sulfate, because some of it has been lost along the way. The mass of calcium sulfate. So the mass of calcium sulfate is the number of moles multiplied by the MR of calcium sulfate. I'd have to work that out. It's CaSO4, so a 40, add a 32 for the sulfur, add 4 16ths for the oxygens, 136.2, and it comes out as 3.6398, but I want it to 3 significant figures because the other values are to 3 significant figures in the question.